So 90 degrees is pi over 2. Now, there were some other angles that we were really interested in last chapter, specifically 45, 30, and 60. So it'd be really great if we knew stuff about those ones. We were talking about right angles. We already got 90 degrees. Let's look at 45, 30, and 60. Now, 45 is nice. So, and all of these are going to be nice because it's radian. So I've got my unit circle here again. I've drawn 0 on pi. And what I've done is I remember that, hey, well, straight up is 90 degrees. If we cut 90 degrees in half, that's 45 degrees. If I cut this thing into 4, that's going to behave the same as a 45-degree angle would be, because it's half of a 90 degree, or half of a pi over 2. So if I've cut this pi into 8 pieces, I've got 4 on the top, 4 on the bottom. So as I move around this thing, we get this one to be pi over 4, because I've cut that top part, that top pi, so all the way around is 2 pi. So the top part is half of 2 pi, so 1 pi. And I cut it into 4 pieces, so a quarter of a pi, pi over 4. The next one is 2 pi over 4, because I've got 2 of those pi's over 4, but hey, that's pi over 2, that's 90 degrees. We already did that one, so that's not going to be part of our 45-degree family, our pi over 4 family, because it's part of the 90 family. So pi over 4 is going to be important for us. 3 pi over 4 is this one over here. The one down right here is 4 pi over 4, but hey, that's already part of the pi over 2, so we probably don't want that one. Plus the 4's kind of go away. Then this one is 5 pi's over 4. And look, I'm just counting things. We got 1, 2, 3, 4, 5 pieces of pi over 4's. The bottom one is 6 pi over 4, but that's 3 pi over 2. We've already done that one. The final one is 7 pi over 4. Look at this nice pattern that's happening with the 45 degrees, which are pi over 4. That all the ones that are not included in other families are all like a pi over 4. And it's not like I skipped any. I went all the way around. It's not like I was like, well, I don't really want that one, but I've got pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. The only ones that stayed as part of this family were the ones that didn't simplify into something that would fall into another category where it would make more sense. These are the angles that are making kind of that 45-degree shape. All the other ones are making more than 90-degree shape. So the pi over 4s are one of our kind of like angle families, 45-degree angles, ones we cared about before. But now I can identify much faster. It's something over 4. Take a look at, here's another one. Let's take a look at 60. So 60 degrees is a little trickier to visualize, but I've made a poor drawing here. But 60 degrees, that's a third of 180 degrees, a third of 180. You cut that into 3 pieces, you got 60 degrees. So I'm going to take that pi, and I'm going to cut each piece into thirds. Okay, well, this one, notice it doesn't land on our pi over 2. It skips over that, which makes sense because 60 is not a multiple of 90, but 45 was, so it did land on there. So if we've cut this into thirds, this first one right here is pi over 3. The next one we come up with is 2 pi over 3, because I've got 1 pi over 3 slice, I've got another pi over 3 slice, and I've got a third pi over 3 slice, 3 pi over 3. But that's not part of this family because it's part of the 90-degree one, because it didn't simplify, which is good, because though that flat one is not really making like a 60-degree angle, is it? The 2 pi over 3 and the pi over 3 are. Go down into the next quadrant. We've skipped 3 pi over 3. We go on to 4 pi's over 3. And the last one is 5 pi over 3. 6. Why am I getting 6? So this is our family of 60-degree angles. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Look, it's still kind of getting that same pattern. Before we had all 4s in the denominator. Now we have all 3s in the denominator for these radians because they fit nicer together. When you talk about these same angles in degree, it's 60 degrees, 120 degrees, 240 degrees, and then 300 degrees. Like, what is the pattern there? I don't see the pattern as clearly as I do when it's screaming at me in the face in radian. Radians are just better than degrees. I'm not going to work through it, but this is the one for 60 degrees. There's a lot because it's a very small angle, but you do get a nice family again. Because 30 degrees is a multiple of 60 degrees, we get a lot of repeats. It's also a multiple of 90 degrees, so again, we get a lot of repeats. But you can see that family of 30-degree angles, the littlest ones, that they all are over a 6. Everybody else simplifies into some other family, the 90-degree family or the 60-degree family. I wouldn't worry about getting this whole diagram because you've really drawn this whole diagram already. But what I care about is those 4 that I circled because those are our 30-degree angles. But now they're pi over 6. And now we come to this. This is the whole caboodle. This is not just the golden nugget of today. This is the golden nugget of everything that is radian. We've got a couple of things that we're going to be adding to this thing, just a couple. But I want you to devote like a whole page of your notes for this thing. This is something that is totally worthy of going into your happy function book. Just give it a full page of your happy function book. This is the golden nugget. And what's so great about this thing is it's got everything that you need to know in order to figure out any kind of angle that you might need. So over here on the side, I've got all the conversions, the major conversions that we came up with today. The 30-degree angle, the 45-degree angle is pi over 4, 60-degree angle is pi over 3, 90 degrees pi over 2, got 180 is pi, and 360 is 2 pi to represent that going all the way around. Now, this is just the corner of a coordinate plane. So it's just quadrant 1, but it's not worth drawing out all the rest. The textbook does all the rest, and I kind of hate it. More about that next time. But then along this side here, I'm actually writing coordinates, and you might recognize these from last chapter. We made these coordinates last chapter about how here, if our radius is 1, our r was 1. Last chapter, I was like, I want to make this diagonally hypotenuse 1. I want a radius of 1 because I was prepping you for the unit circle. So we've got cosine is these angle values right here. Pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. And the cosine of pi over 3 is 1/2. Get this thing written down in your notes. This thing is everything. And that's it for today. We're how we can apply a lot of these things. We're going to be playing a little bit more in class. But for today, I just want to get you comfortable with talking about how we convert back and forth between the language of degrees and the language of radians. Because making sure that we can speak radian fluently is going to be very, very important for us. Okay? Thank you for watching. Have a good day.